Okay, the load testing is in progress, and we have a test that's running since 4 p.m. Central, 26% done. Now this load test produces about 200,000 dialog steps per hour, comprises of 5 major business processes: SEM, operations, some time entry application, and various logistics transaction. We have a fair amount of tests completed. These are business process transactions that are completed. And in progress, we have about 200 users per app server, which is about 600 users. These are in progress. A few transactions that have failed. So we'll be monitoring the ones in progress. This test is designed to run for 10-minute ramp up with a 15-minute runtime after that. It's about an hour plus maybe 10 minutes for transactions to progress and finish. So let's look at the result of the test. So far, we have I/O measurements in the database. During steady state, we're looking at average write times. There are about 1.6 milliseconds per operations to the SQL Server I/O files. Reads are averaging about 2.6 milliseconds, and then an overall average of about 1.7 milliseconds. And we're pushing about a megabytes per second on the reads, with a lower number on the writes, about close to 250 kilobytes per second. So that's from an I/O perspective. Let's go take a look at overall response times. Average app server response times are 370 to 380, 390 milliseconds per dialog steps, with about 12 millisecond DB request time. So this DB request time is an indication of how well the performance of the database per SAP generated either direct read, sequential read, or an update, insert, delete. That's an average DB request time. And as you can see, we're also monitoring the file I/O access times. Since the test started at 4 p.m. and ramped up at 10 minutes, the steady state goes from about 4:15 to about 4:45ish. So we should be getting updates to this. The initial ramp up is normally always a little high as the transactions come in. We are running without any diagnostic or traces on the system, and sometimes SAP IZ20 updates the file stats every 15 minutes, so this screen here will not refresh until 4:30. We expect this number to drop down to somewhere close to 2 milliseconds per access, as we can see from the I/O stalls being reported in the DB cockpit monitor. Let's take a look at what IT Conductor, which is our monitoring tool, hooked up and monitoring the environment. We have the overall performance of the PE1 system. Currently shows the last test that we did. I should refresh here soon, but the average dialog users on the system to be about 600 users. CPU consumption per application server, we're only utilizing 3, which are in the log-on group, and the other 3 are excluded in the graphs, but generally they are averaging around, I think, 25 to 30% utilization on the CPU, which about 200 concurrent dialog users. The users, we have configured them to be a high interactive user, which means that they are hitting the keyboard on average about 5 seconds per interaction. Test, as you can see right now, is about 50% complete. Go back at the next point around 4:30, we should get another refresh in statistics. We've been in steady state about 17 minutes, so we've reset the stats. Still averaging around 2 milliseconds overall for file I/O access to the SQL Server data files. That is within acceptable performance, between 1 and 5 milliseconds. The write times are looking fairly good at about 1.5. So let's go back and look at transactional performance, see if we have some information on that. Currently okay, so we do show these are the tests that performed earlier in the day. We've had 4 tests and averaging about an hour each. They peak around 6-10 users, maybe a little bit higher. And as we did the first test on SQL Server Node A with a 1 LUN configuration. In fact, actually there were 8 LUN configuration, but 1 aggregate on a net app. So both of them perform identically. The second set of tests we did in the afternoon, test number 3 and 4, were on 2 different database nodes, both of them configured with 8 LUNs and spread out more over 4 aggregates over on the NetApp side, so there is more I/O spread across multiple headers on the NetApp SAN. That means they access to more cache and more CPU processing for the storage I/O. And this 5th test that we're doing is exactly the same configuration as the 3rd and 4th, but without the tracing turned on at the SQL Server for I/O performance. This is a measure of DB request times that are seen by the application server. So we'll get updates to that a little bit later. We're also seeing transactional response time versus the dialog step count on the system. I'm getting a refresh. This is a measure of dialog steps per interval of 30 minutes, and our response times calculated based on that. So this morning the average response time is somewhere around 100 milliseconds. The dialog of about over 100 something dialog steps per half hour. So that's kind of the load profile. Here's where the transactional, we measure transactional response time by the business transaction. So these transaction code belong to the business process, and we do measure their individual transactions. So the T code in SAP. We also have individual user as well. So each of the test user, for instance, every time we run a transaction is also being measured, and we can report the components of their response time based on that. And we'll circle back. I will expect another update to this chart here within about 5 minutes, what the I/O response time is. But right now, we're still pretty steady, around 1.6 millisecond for writes and about 4.5 for reads. There's not a lot of reads going on, so cache is should be fairly good serving the request. Overall response times on the I/O is still around 2 milliseconds. Yeah, so we did get an update here. They lower down about, I guess between averaging these would be about 2 to 3 milliseconds. SAP's response time as far as the load so far is still around 370 milliseconds with a 12 millisecond DB request time. So as we can see, let's go back to the test and see how much more we have on the test. Reconciling the test, which basically checks the transactions and measure them against their status of completion. About 60%, 66% done. So completed. Each page is about 20, so we have about 80. So we have quite a few that's completed. In progress, so we should have about 500 plus users on the system in progress. So each of these transactions can contain multiple, of course, business process contains multiple transactions. So for time entry, there are actually 15 iterations of time entry inside a single business process. For ops, this one contains one transaction. That's a long transaction. This one contains a series of related transactions. So for instance, create notification, and then that notification is used in the subsequent change notification, create an order, and then the order creation then is used in the next transaction to change the order. So that's that ops business process. For service entry, this is supply chain. This uses a blanket PO, and this transaction basically creates service entry against blanket POs. The other supply chain business process comprises of 4 transactions that are interrelated. So ME51N, I believe, creates purchase requisition. 54N, I think, updates that, release it. 21N creates the order, and then Migo, I believe, updates and release the order. So all of these are related transactions. They pass data from one to the other. So that's kind of the business process mix, and these are the instances that are run against the test. So during the test run, we can reconcile, see the progress of the test, as well as get into detail, monitor the test. Each test we can actually monitor in detail by time slice, what transactions are running, what their end-to-end response time is. So what that is pulling up, let's take a look at this again. So we are still reporting under 2 millisecond overall response time for the I/O, 1.6 for writes, and about 4.4 for read. Steady state, roughly making about 1.2 megabytes per second database. And response time is still hovering around 360, 380 for app server, for dialog steps, with the DB request time 100, about 12 to 13 milliseconds We have about 200, it varies about 220 log-on users on each app server. Still pretty good. So here we are with the test monitor, so we can actually see the transaction mix that are running in the system, the active users running these transactions, as well as the average transaction time that we see here. So they're color-coded. What this is the actual end-to-end transaction time when they start the transaction until they finish the transaction, not the dialog steps. We have concurrency as well. So as the test is right now about 27 minutes into steady state, I think we have another 13 minutes before user completes their logon, and then there'll be about 10 minutes worth of user tapering off at the end. 76% done with the test. So comparatively, let's go take a look if we had some. There you go, 4:30. Yeah, so the I/O response times per dialog is seems like a little higher here, but actually 3, 4, 5, 3. So there might be a little bit of misalignment between this data and what we do see in the I/O stalls reported in itself. Seems to be around 2 milliseconds. This data here is basically compiled by SAP, so there might be a lag between this information and the information available in CCMS monitor. But really it's averaging around 2 to 3 milliseconds. Yeah, as we get into a little bit more steady, it's gone from about 12 milliseconds to 13 milliseconds per operation, the database. We'd like to see that number as low as possible, preferably below 10 milliseconds, but so far the test has shown that configuration of 8 LUNs over multiple aggregates seems to provide a more optimal performance from a read-write. There may be some other tuning in the back end regarding number of spindles as well as the cache allocation so that the writes can complete faster. But these files here are performing fairly well, under 2 milliseconds, with database synchronization turned on between node A and node C for replication. It's in async mode, which we know is about 0.4 millisecond impact when it's replicating from one node to the other for high availability purposes. So the failover can happen, within seconds, 5 to 10 seconds, really, if there's a database outage or a manual failover. Let's go take a look at some of the charts here. That one update you a little bit later. Yeah, so our transaction response times from Migo. These are aggregate and reported on transactions from earlier in the day. Every time a user runs a transaction, they get recorded and repeated and reported on. Here's where, for today's test, we have ME21N, database portion, database times 6 milliseconds versus CPU time 35 milliseconds. We are discounting the GUI and the net time because that's generated from the user front end, which we're sharing a server that generates loads for 50 to 100 users each server, so there is a little bit overhead of GUI time. So essentially, most of the law is cooking under 200 milliseconds. Very good. This is a user base, so I guess the user we have this particular test user has a response time component. So GUI time is mainly the one. time can be excluded. You can see here the user times for everything that the user runs can be reported upon. Essentially, each time the user runs a transaction, it gets recorded. So this user happens to run these cross-section of transactions. Their response time is shown, dialog steps, GUI times, and DB times. These are actually in seconds, so that might be why they show up as high. But we can click on these. This will pick the top 10 DB response times out of that period that we recorded. So any of the blue fields are going to be top 10 on that context interval. So let's go through that after doing some best correlation of that. So in this case, if you click into the transaction itself, we should see the detailed information of that transaction at runtime by that user. I believe you can view. So this ML81N single dialog step, we have the ability to see the actual detailed record. So response time was 1 second, and we go down, we see DB should have total DB time. So that was 8 seconds, but the average time DB processing would be the number of records that retrieve divided by the time. So that's 244 millisecond DB time for this particular transaction to run 33 dialog steps. Go out again. Yeah, so in another 5 minutes or so, we should have another print here. It's expected to come down a little. As always, the beginning of test, and then here's our IO demand. Yeah, so our test ramp up to about the same set of users during the peak of the test. So we should have one more bar here to complete our test. Let's go back to this IO chat. All right, so flipping back, just check again. So IO times average is still under 2 milliseconds. It's about 1.9. The writes are about so under 1.7 milliseconds. Reads are somewhere around 4 milliseconds. Our rate is about similar, about 60, 70 writes per second. Kilobytes is still hovering around 1.2 megabytes per second. So the next refresh we should see up here pretty soon should be 1645. Well, that will be one second last read we'll get on this. Again, it's still hovering around 13 milliseconds per DB request time. Average overall on each server. So this number should be lower once the network latency between application server and database server gets lessened or tuned. I think it's still a little high here, probably network latency on TCP/IP transfer between the SQL client on the application server and the database. Again, looking to refresh this soon and see. So 1645. And now it's showing the numbers that we expect around the 2 millisecond right in the middle of our test. So we still have about 200 users per app server. And the test currently should be somewhere around 85%. So let's reconcile the test. Test is reconciled, 94% complete, so we should be completing in about, so we started at 4 p.m., 10-minute ramp up with a 15-minute runtime. It should be completing in about 10 minutes, 15 minutes. And these are the completed ones. In progress, about 500. Business processes are running. Tanka entries tend to be a long-running one. diagnostics and not something else. There should be other things running. So some of these are dependent on the business process ahead of it. And just curiosity, you click into one of these to see the transactions progressing along nicely. So each of these transactions, if you click into them during the test execution, we don't see it because we don't turn recording details on, but during verification we would see each individual screen and data that is provided, including the screenshot of the SAP GUI screen. Stepping back. So again, the test is moving along nicely towards the tail end, the last 15 minutes or so. This time, we should be able to get our data snapshots and the statistics for the test. Again, we're still showing under 2 milliseconds overall per I/O operation to these SQL Server data files. So it's holding pretty steady, looks pretty good. The milliseconds per access, again, should correlate to these I/O stalls operation, and averaging between 12 and 13 milliseconds for the DB request time, and SAP transaction response time for dialog step is roughly around 316 to 370 milliseconds. Okay, so the test might be wrapping up soon. Let's take a look at what are the data that may be interesting. So right now we show these are supply chain transaction Migo. This is actually their CPU utilization on the box. You can actually add different context to the analysis. Adding a chart on that to see number of users stacked up against the CPU and the response time for a particular transaction. So almost any chart we can put troubleshooting context on there to help us see what else is going on during that same synchronized period of time. Anyway, that's pulling it up. Take a look at that. You see we have a new updated. We should be getting this here pretty soon. It takes a little while to collect the data and aggregate it, show it up on the chart. So trend analysis. We're seeing CPU should be holding steady. Yeah, roughly 24, 25. We can actually see them in the grid format. If you prefer that, you can export it out to Excel if you want to report anything. So during the test, you can see CPU utilization on the boxes are below 25% on average. So these are virtual app servers sitting on VMware and then shared over physical ESX cluster. And we back down, we can see the overall utilization of the environment. Just always nice to see various different metrics on SAP compared to other metrics happening at the same time. So this would be dialog response time versus users on the system, CPU versus any paging activity. We saw this earlier iteration to the test had high paging activity, but we resolved that issue on the app servers. Now we don't see it at all. Extended memory utilization is how much of the SAP extended memory, which is where stores user context, is how much of that is utilized. So they are under 20%. And any of those processes are in private mode, which means they exceeded their online extended memory allocation. They start going into private memory mode. And how many? So we don't have any of those during this test. It's good. to refresh this chat to see if there's any more update on the dialog splash time. It's another system IO time. So again, monitoring this is called a service grid in IT Conductor, which basically discover and monitor the SAP environment. Alright, so we do have that update. It is around a 2 milliseconds as we expect in the test, so it spikes up and averages out about 2 to 3 milliseconds. That is good. So at this point, I think we'll take a snapshot of some of these for the data during the load test, and we should be completing the test pretty soon. As far as the test is concerned,